Okay, so just a few practice problems related to our data distribution with a dot plot. The class size of 8 first period class sizes is randomly collected from a high school, and those numbers are 8, 18, 16, 19, 24, 21, 19, and 18 students. So we're asked to create a dot plot for the data with an appropriate scale and ask if the class of 8 is an outlier. So let's go ahead and put these numbers on here. So each one I'm going to use, I'm just going to start with 8 and we'll go up to 24. So 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. I'm going to put in 8, and then we have an 18, and then 16, 19, 24, 21, 19 again, and 18 again. Okay, and so first off, we've got to find our values here. So let's put these in order. So we have 8, 16, 18, 18, 19, 19, 21, and 24. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 8. All right, so my median here is going to be 18.5. That's our second quartile number, which means our first quartile is going to be the average here. So 17 is going to be our first quartile. 19 and 21 will average that to get 20 for our third quartile. So first quartile is 17, third quartile is 20, so the interquartile range between those is 3. And the question is 8 an outlier? So we're going to take that first value, 17, we're going to subtract 1.5 times 3, and we get a value of 12.5. So the question is 8 less than 12.5? And it is. So 8 is an outlier. Okay. All right, let's look at the second question. So an additional class with 34 students is also recorded from this original set. Is the class of 34 an outlier? So again, we have these a little bit different on our numbers now. We're going to have to recalculate our numbers. So we have 8, 16, 18, 18, 19, 19, 21, 24, and now 34. So our middle number here is going to be a second quartile of 19, which means that our first quartile is still going to be an average. It's going to be 17. And then we're going to have to average here to find our third quartile. And if we average 21 and 24, we get 22.5. So our interquartile range is going to be 22.5 minus 17, which is 5.5. And so the question is 34 an outlier? So we're going to plug that value in to the other equation. So I have third quartile, so 22.5 plus 1.5 times the interquartile range, which gives me a value of 30.75. And then I have to see, is 34 greater than 30.75? In this case it is, so 34 is an outlier as well. Alright, so now we have this question. Suppose the class size of 8 first period classes are also randomly collected from a neighboring county's high school. Those class sizes are 25, 21, 25, 27, 29, 27, 37, 34. And we're asked to create a dot plot for the data with an appropriate scale. So let's do that first. So I'm going to do 21, 23, 25, 27, 29, 31, 33, 35, and 37 here. And I'm going to go ahead and fill in those values. So I have 25, 21, 25, 27, 29, 27, 37, and 34. And second question, in terms of distribution of data, how do these 8 classes compare to the 8 classes from the first high school? So the first high school, we look at that and it looks like the data is mostly over here with that one outlier out here. So I would say that the first high school data is skewed to the left and has one outlier. We're not considering the one that we had in the second question here, just in the first, and so 8 is the only outlier that was there. Now, the second values we have, looks like it's a little bit more skewed to the other side, so we're going to say that the second high school data is skewed right. And let's check on our outliers here. It doesn't look like there are any outliers, but if there is, I would say that it was probably this 37 value. So let's check real fast. So first off, we need our first quartile value, which in this case is going to be 25. Then we look at our third quartile, and it's going to be an average of these two numbers, so it's going to be a 31.5. So our interquartile range here is going to be 6.5. Okay, so we're going to do the quick check here. Let's see, so we have 31.5 plus 1.5 times 6.5, and we get a value of 41.25. So there are no numbers greater than that, so we don't have any outliers. And we could check the lower one as well. That would be 25 minus 1.5 times 6.5. Let's see, that would be a value of, do my quick calculation here, 25 minus 1.5 times 6.5, and we would get 15.25. And I don't have any numbers lower than that. So the second high school's data is skewed right with no outliers. Okay, and you may see some other similarities and things that you may think about that. So that question again has a little bit of wiggle room in your answers. It's going to depend on what you see, but as far as the skewed data, whether there are outliers or not, that's no outliers on the second question. It was the first one did have an outlier of 8.